Welcome to the Adapter Design Pattern course. In this course, we'll talk about what the adapter design pattern is, how to implement it, plus we'll look at an example. The adapter design pattern is a very famous Gang of Four design pattern that you should definitely be familiar with as a software engineer. So without further ado, let's jump right in and define the adapter design pattern. So let's start with the definition of the adapter design pattern. The definition or the quote from the Gang of Four book is as follows: convert the interface of a class into another interface that clients expect. Now, when we're saying an interface, then we're talking about the behavior that the class exposes. So the underlying class can be a concrete type, can be an abstract class. What matters is that we want to convert the way you interact with a class from being with one interface to being with another interface. And the reason why we want to do this is because this lets classes work together that couldn't otherwise because of incompatible interfaces. Okay, now the best way to think about this is to really just think about actual adapters. So over here, we have two incompatible interfaces. Okay, so again, the definition is convert the interface of a class into another interface that clients expect. Over here, we have a flat blade American style 2-pin plug. And over here, we have a European style outlet. And these interfaces are incompatible. To make them compatible, then we use an adapter. The adapter takes the existing interface and converts it or adapts it into the interface that the client expects. In our case, the interface that we want are the two round blades, and what the adapter does is it takes the previous interface, we're going to call this the adaptee, it takes the adaptee and it converts it to what we're going to call the target. So when thinking about this pattern, I always want you to have in mind that the old interface is the adaptee and the new interface is the target. And what the adapter does is it simply takes the adaptee and it sort of wraps it and adapts it to the new interface. So I want you to pause and lock in what you currently see on the screen. This is what you need to think about when you think about the adapter design pattern. Okay, so just finishing up on this example, then the adapter pattern lets classes work together that couldn't otherwise because of incompatible interfaces. And of course, in our example, this makes perfect sense because the two interfaces, the plug and the outlet, were incompatible, but using the adapter, then they are compatible. Now, because this pattern refers to how we take two objects and we construct them together via inheritance, via composition, because it has to do with how the objects are structured to simplify the overall design, then this falls under the category of structural patterns. Now, alongside the adapter pattern, then as part of the structural patterns, we also have the bridge, the composite, the decorator, the facade, the flyweight, and finally the proxy. Now, in the next subsection, then we'll talk about the difference between the adapter, the decorator, the facade, and the proxy, because the difference between them can be a bit confusing. Alongside the grouping or the classification of the patterns into structural patterns, we also have the creational patterns and the behavioral patterns. The classification of the design patterns into structural, creational, and behavioral comes from the book Design Patterns, or in its full name, Design Patterns, Elements of Reusable Object-Oriented Software, which is usually referred to simply as the Gang of Four, referring to the four authors of the book. Now, let's say a few words about adapter versus the other design patterns that are similar but different. So as we said, these four design patterns can be a bit confusing. So I want to spend a minute and talk about the difference between them, just so by the end of this course, you know to say, this is the adapter design pattern. Now, of course, to fully understand the difference between them, if you're not familiar with the following three design patterns, then definitely check out the courses on these design patterns here on DomeTrain, because that will give you, of course, the holistic understanding. But in any case, the point of this subsection is to allow you to take a look at a pattern and say, this is the adapter design pattern, even if you're not familiar with the other design patterns. So basically, what we have is the following. The adapter design pattern is a simple pattern in which all we're doing is we're making two interfaces compatible with one another. Like with the outlet example, then all we're doing is we're taking one interface and we're making it compatible with another interface. On the other hand, the decorator pattern, even though it's somewhat similar in the sense that we're taking an object and we are wrapping it, then the decorator pattern is actually about something else. The decorator pattern is about adding behavior to an existing object without touching that object. And the adapter pattern is not about adding behavior, it's just about making these two interfaces compatible with one another. The facade pattern is about taking an object where the underlying behavior there is very complex or the interactions are very complex. Maybe there's multiple objects, creating a facade that you interact with to simplify the interaction of the client with the underlying object. Finally, we have the proxy pattern, where the proxy pattern is about distancing yourself from the underlying object that you want to work with by creating a proxy. You interact with the proxy and the proxy interacts with the underlying object, where you may want to lazy load the underlying object. You may want to add logging or just manage the lifecycle. There are various reasons why you'd want to use the proxy pattern, but the core idea is that you're working against some proxy and the proxy interacts with the underlying object. So again, adapter pattern is about making two incompatible interfaces compatible. The decorator pattern is about adding behavior on top of an existing object without touching that object. The facade pattern is about taking a complex system or a framework or a bunch of classes or just one very complex object and simplifying the interaction with that entire part of the system by creating a facade and interacting with the facade, and that facade goes ahead and interacts with the complex system. Finally, the proxy pattern allows you to distance yourself from the underlying object that you want to interact with by interacting with a proxy and letting the proxy manage the interaction with the underlying object. So this is just a brief overview of the various design patterns. And just what I want you to have in mind is that the adapter pattern is about making two interfaces compatible. That's the reason why you would apply this pattern. You have some object that you want to interact with, but it's incompatible because you're expecting a specific interface. You may want to create an adapter where you interact with the adapter, and the adapter goes ahead and interacts with the underlying incompatible object. If you're not familiar with the other design patterns, then definitely check out the courses here on DomeTrain because it's important to fully understand what these design patterns are all about. So now that we're starting to understand what this design pattern is all about, let's go ahead and create a class diagram. Okay, so on one side, what we have is the client. The client wants to interact with some interface, but that interface is incompatible to what the client wants. Okay, so we have the client, and the client wants to go ahead and interact with some type that is incompatible. We said we'll call this the adaptee. So we have the client. The client wants to go ahead and use the adaptee. Now, when we say use, then what we mean is that there's some method over here. Let's call this the specific request method. There's some method that the client wants to use. In the previous example, then this was the American style plug. So there's this method that client wants to interact with, but it is incompatible. So to make these two components compatible with one another, then it uses an adapter. The adapter is also a class. Let's go ahead and call this the adapter. And the adapter knows how to adapt the adaptee to the client. So let's imagine that there's some method called request, and this is in the end what the client wants to interact with. This is what it knows how to interact with. In our previous example, this will be the European style plug. The adapter and the implementation of this request method, then it's responsible to know how to take the adaptee and make it compatible with the client. Okay, so we have the adapter, and the adapter goes ahead and uses the adaptee. Now, the client will use this adapter, but only in runtime will it use the concrete adapter that will go ahead and use the concrete adaptee. In compile time, then what the client will interact with is not the adapter, but some interface, which will be the target. So let's go ahead and call this the target. And the target will have the method that the client wants to interact with. In our case, it's the request. The adapter will go ahead and implement the target interface. So overall, what we have is the following. We have the client, and the client in the end wants to interact with some adaptee. To interact with this adaptee, then in runtime, it goes ahead and uses the adapter. Now, it's not interacting directly with the concrete adapter, but instead it interacts with some interface which has the method that it needs to interact with. And this is implemented in the adapter. Going back to our example, we have the European outlet being the client because this expects a European plug. But you're just coming from the US and all your appliances are using an American plug. To go ahead and make the two interfaces compatible, then we're having the client interact with some interface. This interface that it needs is the actual pins, the round pins of the European appliances. So this is the round European plug. This is the interface that the client expects. This over here is these pins in the adapter. The adapter is the one that takes the adaptee, which has the American flat pins, and converts them to the European round pins. So that's the pattern, pretty intuitive when you think about the real world adapter, but I also want us to take a look at a more concrete code-specific example.